the constructor will allow us to turn the class into an object. It will build it for us. We learned that if you want to use a constructor, if you want to build a constructor with something, for example, if I have a class name, so over here I have the class's name, I would then bring the word I want to use as my object name. So here we'll have the object name, and then I'll say it is equal to new, the class name, then into curly brackets, whatever object, whatever parenthesis in which it is going to go with would come here. So over here, the object name, it is a name I am given. It is not fixed. I can give any name I want. For example, when you guys are creating the scanner class, you say scanner, then you put any word you want over here, maybe display or corn or whatever you want to put over here. Then the keyword new, then you say scanner into brackets. Then in here you put in system.in. This is how you create the object of the scanner class, whereby the object is the word display. Again, over here, I can put in any word I want. If I want, I can even type the Hewlett. And it is fine. So far as I have a name in which I am giving my computer, the name over here takes up the object. That is how I am creating the object. That is how I am creating the physical thing I can use. The class name is the rules. So that will define the things I can do with it. But to use it, I need to create the object. And this is the format in which we use to create a particular object. Now, it is also important to know that this side of it is very important. The first side of it, the first side of the equation, that is this half. It is the same as you doing int number one, okay? When you do int number one, you are telling the computer to create a space for you and make the space have properties of an integer. So over here, I'm also telling the computer to create a space for me called Hewlett, and then it should have the properties of a scalar class. But the reason why over here we do not do is equal to new int into bracket is because the computer already has the properties of the integer inbuilt. It doesn't require you to tell it how it should utilize or run integer values. So we don't bring this. But for the new thing you created it. So you have to tell the computer that, okay, once you create the space, go and pick the rules that govern that space from this place. That is why the new scanner into bracket system.in is there. So that the computer knows that the space I've created called Hewlett, these are the rules that govern that space. These are the things which make that space work. Are there any questions so far? Are there any questions so far? Okay, so to our question. Now, the reason why these questions are given to you is because we as a group have to start learning real world situations. How do we write our code to suit the real world that we are in? How do we write it so that we take information about the current state of affairs that we are in? So, in this example again, They said, imagine you are tasked with designing a vehicle management system for a logistics company. So this is what we want to do. We want to design a vehicle management system for a logistical company. Hence, over here, I'll copy this word here, that is vehicle management system. I would open up my IntelliJ. I will tell IntelliJ that I want to create a new project. The new project is going to be called Vehicle Management System. I'll make sure it is one word so that there are no spaces between it. And then I'll click on Create. Once I do that, I have this window here created for me to write my code within. In here, I would delete all the boilerplate code that was given to me. I do not require it, so I'll just remove all of them so that I just have my main method ready for me to write any code in which I require. Hello, can you hear me?
Yes, sir, we can hear you.
Okay, so sorry. I just want to remove one of this. Yes, that's this can go away. Good. So I have my main class done for me. This is my main class. It has all the main variables I require. Everything is fine. I have no errors. Everything is okay. Now, back to the question again. Please take note of how I am solving it, because most of the time you'll be alone. Most of the time when you are faced with questions like this, you panic and then you start to imagine the question as something which is not. Take your time, step by step. First of all, know what they want you to do, know what is required of you, then you move from there. Now, in this question, they said the company operates a fleet of different types of vehicles, including cars, trucks, and motorbikes. Let's take this statement alone. In this statement here, we can see that cars are vehicles, trucks are vehicles, motorbikes are vehicles. So they are technically telling you that, okay, all of these things here are derived from this. So I can tell the computer to create this for me, and then I can allow it to specialize and move into the various ones later. So for now, I'm going to create a class called what? Vehicles. So in here, I'll just right click here, go to new class, type in the class name in which I want, and then press what? Save. So over here, I want vehicles. Remember, if it is a class, it must start with a capital letter, so I'm starting it with a V. And then I'll click in, and I have created a class called what? Vehicles. Now, the next thing I have to do is tell the computer what are or what is the variables / attributes and what are the methods / actions that it is going to perform. So over here, I'll start with the attributes. What makes something a vehicle? If we say something is a vehicle, how do we know that that thing is a vehicle? So I will start off by saying string the name of it, string the model of it, int the year it came out, string the vehicle the vehicle type, int the mileage of the vehicle. Now, let us look at this thing here critically again. I said string, the name of the vehicle. It is a name. Oh, sorry, the make. The make of the vehicle. So the attribute is make. Why am I adding string to it? Why have I given it a data type of string? Because I will have to type a sentence. If it is a Toyota, if it is that, if it is that. Hence, me typing that information as a group of characters makes it a what? A string. The same thing for the model number. For year, a year is 2004, 2005. It is an integer, it is a whole number, so I'm using it. Over here, I have string vehicle type. I have its mileage because the mileage is measured in 4 miles, 3 miles, 5 miles. If we want to be technical about it, maybe we can say the mileage, we can make it a double because in the mileage, maybe there will be decimal numbers there for it to be carried upon, if you want to make that argument. So over here, I've given the attributes of it. Now, in the main function, I can then go and tell the computer that, okay, go and pick the vehicle class in which I am using. The vehicle class, I'm going to call it what do I even call, what name do I even give to this object? One second, I'm totally blockheaded on the name I'll have to give. Let me call it vehicle one. So here I'll call it vehicle one. And it's going to be equal to new vehicle into bracket. The key point, let me see if I can make this bigger so that those of you out there can see a bit better. So what? Appearance. What? Okay. So the font here, I'm going to make it 23. Apply it and press OK. Okay. So over here, I've just created a space. The space should be able to take vehicle information, and I've given it all the properties of vehicles. The question that comes in here, this vehicles with the parentheses at the back, where did it come from? What is it? Because over here, I do not have it here. You can see that the vehicles over here, it doesn't have any parentheses over here because it is a class. And when we are writing classes, we don't add what? Parentheses. So over here, it's starting with a capital letter, which means it is not a method. Why do we have this piece of information over here? Why is that there? Because in here, it is not there. Now, this thing here is what we call the constructor. This piece of code here, where you have a class name and then the parentheses beside it. That is what we call the constructor. The constructor is used to build the object. Now, in here, as I said, when we do this, we give it the properties of the class we have created. In this case, vehicles. So we are taking all the properties. In this case, we are taking all of this and giving it to the space we have created so that the computer can know how to handle the data that we are going to give to it. So the constructor's job is technically to build it because it is giving it the properties. It is showing it, do this, don't do this. If you do this, this is where you get an error. All of those things, it is used to build it. So that's the job of the constructor. The problem is that in here, we don't have it here. So why is it that when I bring this here, I don't have an error? Why don't I have an error? Because it is not there. Technically, when you create a particular object, the computer gives you certain rules and attributes that go with it automatically. For example, if I type vehicle here and I press a dot, we can see that the model, make, vehicle type, mileage, and year that we created over here are all there. So the computer is showing us all the things that we created, which is great. But we did not create is equal to. We did not create hash code. We did not create toString. We did not create get class. All of the things in which are here that you can see on this screen here, we did not create. That means whenever you create a class, the computer gives you all of these things as part of the class you create. That means that technically in here, the computer creates its own constructor for you to have as a default. So in here, you can see that the computer will create its own constructor. And the constructor that the computer will create, starts with public. And at this point, we need to talk about this public keyword here, because there are 3 forms of these kind of modifiers. We call them modifiers. And the modifiers we have we have protected, we have public, and we have private. I would use protected when the thing should not be changed. Okay, so no change. I would use public when another class can have access to it. And I will use private when another class cannot have access to it. Now, over here, I am writing a modifier. I'm writing a constructor. The constructor is going to be used by another class to create an object. So if I make the constructor private, it means I can never create my what? Object. That's number 1. Number 2, the reason why we make it private, obviously, is so that the other classes can have access to it, very importantly. So it is public. The next thing we do is write the name of our class. So in our case, the class is vehicle, so vehicle. You bring your parentheses and then you bring an empty body. This here is created automatically for you whenever you create a class. So technically, you don't have to create this. The problem is that if you are going to use the default, everybody knows that the computer automatically creates a default class for you. That means that if I am a hacker, if I'm someone who wants to destroy your application, I will just create it and utilize whatever resources in which you have. So it makes sense that you would create your own and leave the default away. So in that case, we have this as the default. When I come in here and I press a dot here, I can tell the computer that, okay, here dot model is equal to, let's say, Toyota or something, okay? Toyota or something. That's fine. This is perfect. This is okay. The problem is that as a rule of object-oriented programming, there is a rule called encapsulation. And if I write my code like this, I am not following the rules of encapsulation. And what does encapsulation say, or what is encapsulation? What is the abbreviation of encapsulation, and what rule does encapsulation tell us to do? before I say that, are there any questions so far? All right. So over here, encapsulation refers to the concept of restricting direct access to an object's data, that is the attributes or the fields, and only allowing modifiers or retrievals through specific methods, often called getters and setters. If I am a person and an object is a person because it either has feelings or not, we have spoken about this at length. So if I am a person, my innermost thoughts are kept to myself. There should be like if I want to travel, if I want to sleep, if I want to do any of these things, I know it. Unless I want to tell you, it is upon me to know it and keep it to myself. So the whole point of a constructor is that another class should not have direct access to the places in which you save yourself. I should not be able to do vehicles.module. It shouldn't be possible. It should be hidden away from you so that you do not have direct access to my innermost feelings, my innermost thoughts, my innermost data. You shouldn't have access to it unless I want you to have access to it, and in a way in which I want you to have access to it. So back here in vehicles, I need to make a change to all of these things here so that this other class called main would not have access to the innermost thoughts of it. In doing that, I will change this to private. I'll change this to private. I'll add private over here. I'll make this also private. And then finally, I'll make the int also what? Private. Now, making it private, the computer immediately tells me that, hey, over here, you have a problem. And where is the problem? It is here. It is here because now, if I type my vehicle one and I bring my dot, we can see that the mileage and things are not here anymore. They are not here because they are private to this one, and you, as main, cannot have access to it anymore. It is hidden from you. It is protected from you. The problem then comes in over here. How will I get access to the data over here? Because I need to put in some values over there. I need to tell the person the make, the model, the year, the vehicle type, and the mileage of the particular vehicle. I need to inform the computer what values do these things have? What are they? So in order to do that, there are two ways I can do that. First of all, I can use a getter and a setter to do that. That begs the question, what is a getter? What is a what? A setter. So back here, I'm going to create a function. In your previous class, I know you did functions, so I know you know how to create a function. So first of all, I need to give the modifier. So in our case, it's going to be public. Then I need to give the data type of the method. It's going to be void. Then I need to give the name of the particular method. So over here, I'm going to say set make. Then I'll bring my parentheses. And in here, I'll say string make. Then in here, I'll tell the computer that the make outside is equal to the make inside. Now, when I do this, the computer immediately flags an error over here because it's like, what are you trying to do? The thing has nothing in it. And you are saying that I should make the thing equal to nothing in it. How is this possible? This doesn't make any sense. The idea is that we are asking the user to put something in here. We will take that thing and make it equal to the thing we have here. That means that this make and this make are different. This is one space. This is another space that we are putting data in. Now, the make, if we refer to make over here, technically, because this is closest to this body here, this one to this one makes it one environment. It means that the two makes we are specifying over here is talking about this one. You can see that the moment I highlight it, the computer is highlighting this. It does not highlight the one at the top because it is local to this. So if I want to tell the computer to refer to the make that is outside, I need to tell it that, no, go to the global make. Don't refer to the make that is local over here. So how do I tell the computer to refer to the global one? I will add this keyword here. So the moment I do this dot make, you can see that now when I highlight it, this is not highlighted anymore, but this is highlighted because now it knows that, oh, I am referring to the make that is outside. That means that now, if I put something in here, it is going to take it and go and give it to the make that is what? Outside. Another question the student will ask is, sir, why is this necessary? Because in the first case, all I had to do was just type vehicle1 dot make, and then it is equal to something, and it will work for me. It will be fine. The computer will take that information and it will work. Now you are saying that we shouldn't make it like this. We should make it private, and then we should go and create this so that this will rather go and take the information. Isn't that too long? Doesn't that not make sense? The truth is, most of the time over here, other things go on. For example, you would make sure that this make that is coming into your computer over here, you would make sure it is sanitized and it is sanitized and it is safe. What does the sanitize mean? Somebody does not enter some keyword to destroy your application, or he doesn't enter something that will make your application stop or any of those things. It is here that you will check and make sure everything is okay before you go and make it equal to the make that is over here. So that if there's any problem, if there's anything that can bring harm to your application, you will stop it here before you make it equal to something. So it's technically like before you will let someone into your house, you would have to pass through the gate. Imagine you have a house that has no gate and every place is open. Anybody can see what you are doing. Anybody can just walk through. That is not ideal. So you have your house. Before you can come to a house, this method here is serving like a gatekeeper, making sure that before you come into the house, everything you are doing is okay, it is correct, it is well pristine, it is well taken care of before you can come into the house. So this here is how you would write a set method. So it will take information. So over here, I'll just say vehicle1 dot set make, and in here I'll put in the make of the car, and then when I put the Toyota here, the computer will take the information I have typed here and then go and give it to the method I have over here. Now I have a way in which I can showcase the make and bring it into my application. How will I display it? So over here, I can bring it in. But now, if I want to display what is in the make, how will I do that? And there's where we use the what? The get. So again, the get is public. But in this case, I will type a data type to it. So I'll type the data type, which is string. It will not be void anymore. And I'll type the name of it. Get what? Make. Note that this set and get, it's not by force that you have to type it set and get. It's just that when you type it set and get like that, everybody knows that, okay, this one here is to bring something in, this one here is to take something out. Everybody who you work with will know because it is a convention. But the idea is that this method here is bringing information into your class, and this is taking information out of your class. So the get word here, I could give it any name in which I want. It doesn't really matter. It's not by force I have to say set or get. The idea is that I should know that, okay, set is bringing information into, and then get is taking information what? Out of. So over here, I'll tell the computer to return make. And when I do this, the computer again is flagging me because in here, there is nothing like make here. So I'll just add my word, this dot, so that it knows that, okay, the make I am talking about is the make, which is what? Outside over here. So what does this do? When I call on this, the computer will go and take the information here and display. So that in here, I can just say system.out .print ln, and in here I can say get vehicle one dot get what? Make. And when I run this, I expect that I would see Toyota over there. So I can see my Toyota over here. I didn't spell the Toyota right, but T-O that. Toyota. So this will go and put the information there, and this will go and what? Retrieve the information for us. Get and set. Are there any questions so far? Isaac, are you there? No sound from Isaac. AL, are you there? AL is
Yes,
not.
I'm here.
Frederick, are you there?
Hello, Zaman.
Yeah.
I'm here.
Hewlett, are you there?
Yeah, Mark, I'm here. I'm here.
Okay. Well, so now the idea is this, right? If I'm going to be using the getters and setters, most often, what we will do is that when we are creating the thing, we will tell the computer to set the values for us. So most of the time when you guys do scanner, OBG, or if I write on, let me say OBG, or let me just use display and before. So when you have your scanner class like this, when you have your scanner class running like this, you see that the first half of the scanner class looks exactly like this. We have your new word here. So the new is here. Then you have your vehicles. You also have your scanner class. But inside here, you have system.in. That means that you are introducing something into your what? Your class. So over here, we are going to tell the computer that, okay, when you are creating the object, ask the person the make of the car, ask the person the model of the car, ask the person the year of the car, ask the person the vehicle type, and ask the person the mileage. Of the car. Now, when you ask the person the make, the model, the year, the mileage, and all of those things, I will have to take the information from here and go and put it over here. So I'll tell the computer that this dot make should be equal to what? Make. This dot model should be equal to model. This dot, what is the next one? Year should be equal to year. This dot vehicle type should be equal to vehicle type. Are we okay? That's fine. Now, I could say this dot mileage should be equal to the mileage of the car. So now we have information over here. That means that in the main method, when I am creating this vehicle, when I'm creating it, in here, I need to type the make, the model, which is a string. So Toyota, what models do they have? Can someone help me with a model of a Toyota?
Corolla.
And then the next thing is the year of the car, which is, let's say, 2001. And then the vehicle type, maybe it is the vehicle is a saloon or something. Let's say saloon. And then over here, I have the mileage, which is going to be 0. Okay. So once I do this here, if I ask the computer, okay, so vehicle 1 dot, did I just delete the getters and setters here? Yes, I did. Okay, that's fine. So now I have a way in which I can get the information in here. I can put all my information in there. And that is fine. Now, to the question. over here. You see, the mileage of the car that we have, the mileage of the car that we have, you do not tell the car the mileage. The car will calculate the mileage by itself. So in here, I'm going to remove the mileage from here so that the car does not have mileage over here anymore. I'm going to go over here and also remove the mileage. So over here, the mileage is gone. But in here, I'll tell the computer that the mileage is going to be what? 0. Because if you get a brand new car, the mileage is always going to be what? 0. I'm also going to make some changes over here as we go along. But I want to use this class to give you a broader picture of everything we'll be doing. All the rules. What are the rules? When do I use a particular rule? When don't I use a particular rule? And how I am creating the characteristics, how I'm using it. Are we okay? Now, if I have taken the mileage from here, and it's not here anymore, I have set it to 0. So when you start your car, it is going to be a mileage of 0. As the car is going along its life, the mileage will change. That means that I have to have a way in which I can change the mileage. And what will I use to change the mileage? I will use a getter and a setter to change the mileage. The getter is simple. I'll just tell the computer public int get mileage into curly brackets. Then in here, I'll say return this dot what? Mileage. So I'm done with the get for mileage. Over here too, I have to set the mileage. So over here, I'll say public void set mileage into brackets. In here, I'll say int mileage so that the person can enter the new mileage. And I'll tell the computer to do some stuff here. That if the mileage in which the person has typed is greater than or equal to 0, then this dot mileage is equal to the mileage the person has typed. Now, if the person goes to type a mileage which is not bigger than or equal to 0, then system.out.print mileage cannot be negative. So you see that in the set here, I'll check some things. I'll make sure things are done right before I'll go and put it there. I know that if I make it direct, anybody can type something there. And that will worry my code. That will worry my experience. That will worry what I am trying to do. Again, in this course, the first course was there to teach you how to use Java. In this course, we are going to go away from how to use Java to how to use Java in the right way. So this is me creating a class called what? Vehicles. I've created a class called what? Vehicles. Now, in the question, they said each vehicle has basic attributes like make, model, year, and type. However, each type also has unique attributes. For example, a car has the number of doors, a truck has a cargo capacity, and a motorbike has an engine capacity. So now that I know each vehicle type, they are saying that, okay, this here is a child of this here is a child of this here is a child of this. And they also have their own attributes and properties. Now, each of us here is old enough to have experienced life a bit. And each of us knows that their parents and their mothers, their mothers and their fathers, they came together to create you. Which means that even if you try the hardest you can try, at some level, you should have realized by now that you have some characteristics that your father has and your mother has. There are days your mother will look at you and say, "What's up, Papa?" And there are days your father or father also look at you and say, "Oh, you look like your mother." Now, in Java, we are saying that if I create a child, so for example, I right click here and go to this and create a class called car. The car here is a class on its own. But the moment I type the keyword extends and I type vehicle over here, that means that this class here is a child and this vehicle here is a parent. So all the things you have over here is given to the child automatically. And then the child will now create its own attributes and add it to the one in which the parent has. So in here, I can tell the computer that if you are a car, then int, you should have a number of what? Doors. Semicolon. Again, the number of doors will be made what? Private. Now, here is where we have a problem. Before I can use a particular class, I need to construct it. I need to construct it. So it means in here, I need to create a constructor for the car. So I'll say public car. In here, I'll say string make, comma, string model, comma, int year, comma, int number of doors. And I'll bring my parentheses here. And then in here, I would say this dot number of doors is equal to the number of doors that the person has. The other question is, what happens to these ones over here? What happens to them? Because in vehicle, we said that for you to create a constructor, you need the make, you need the model, you need the year, and you need the vehicle what type. So in here again, I'll tell the computer that super, and this super word is a very powerful word in programming. It means that if I can say, for example, I can say super dot make. This means that I am referring to the make in the parent class. So over here, when I use super, it means that I am referring to the constructor of the parent. So make into bracket, you make the person will type, the model the person will type, the year the person will type, but the vehicle type, there's no need for me to type it because I know that the vehicle type is a what? A car. So there's no need for me to ask you the type of vehicle you have because I already know that if you are in this place here, which is car, and we are constructing you with the name what? Car. That means that for me to create a car, I will only take this information, go and give this information to the vehicle information, and then just equate this one over here. Why am I not typing all of these things again? Because I'm telling the computer that this car here is inheriting all the properties from the class vehicles, and vehicles has all of them already. So in your mind, for example, when you go to an organization, there are employees. The employees will have all the properties. But when we come down to it, not everybody is the same type of employee. We have admin workers, we have, in the university setting, for example, we have admin workers, we have lecturers, and they are both different. Even in lecturers, we have part-time and full-time. They are both what? Different. Before you have, in the admin workers, you have contractor staff, you have full-time staff, so on and so forth. So now, when I come here into the main class, instead of me typing vehicles over here, I can do away with the vehicles. And in here, I can type car 1 is equal to new car into brackets, all of these things here. And note that for car, we do not add what? Type, because we already know the type. But for car, we will add what? The number of doors. So let's say the car has 4 doors. So that in here, if I say I want to display the car doors or something, I can display it from here. In our case, over here, the number of car doors that we have could change. So I'm going to put in a getter and a setter for the car doors alone. So in here, I'll press alternate insert. And when I press it, this window comes up for me to select getter and setter. And I want a getter and setter for the car doors, and the computer will do it for me. So over here, instead of me typing the code, I already know the format of the code. So now I can make the computer type it for me. They also said that there is another kind of, let me remove this so that I don't have any error anymore. There is another kind of child that the application has. The name of that child is what? We have a track. So in here, I'll just put in track. Remember, it always starts with a capital T. Create a class. And then in here, I am going to create, they said the track has what? Cargo capacity. So in here, I would say private, int, cargo capacity. So that over here, I would say public. Let me use alternate insert again. Tell the computer I want to create a constructor and press this, and the constructor is created for me. But remember that cargo capacity is going to extend from what? Vehicles. That means that immediately it is telling me that the constructor I've created is wrong. Since it's extending, I must have reminiscences of the parent in it. So again, I'll tell the computer, okay, use alternate insert, create for me a constructor for that. And you can see that a constructor is created for me with the make, the model, the year, the vehicle type. I don't need to type in let the user type in the vehicle type. That means that over here, I'll tell the person that the vehicle type he's using is a what? A truck. And then in here, I would create getters and setters. Again, using alternate insert. I'll create a getter and setter for what? The engine capacity. The next type of vehicle in which I want to create over here, I'll go here. I'll go back to the question. They said the next one is a what? A motorbike. And I'll paste it. Create a capital M, create a class. In here, it is going to extend from what? Vehicles. In here, they said that if you're a motorbike, then you have to, motorbike takes engine capacity. So here again, we have public, int, engine capacity. So engine capacity. And then in here, I can use alternate insert to bring up the menu, click on constructor, and then click this. Again, we will not tell the user to enter the vehicle type because the vehicle type is going to be what? Motorbike. But the other things will be set from that. In here again, I'm going to create a getter and a setter for what? The engine capacity alone. So now in this question here, I have done this part of it. I have done all of these parts. The management also needs to maintain a record of each mileage, which can change over time as the vehicles are used. Full stop. So now let's come back to the question. Where can we find the mileage? We can find the mileage in the class called what? Vehicles. We can see the mileage over here. And we have done that. We said get mileage, and here we can set mileage. So we can set the value of the mileage and we can change it over time. So we've done that. When you start, your mileage is 0. Over time, your mileage will increase and go up. That is fine. We've done that. Let's go back to the question. When creating a new vehicle, the system should prompt the user to enter all relevant info, and each vehicle should be initialized with its data using appropriate constructors. We have done this. You are also needed to track the total number of vehicles in the fleet at any time. Full stop. That means that when I come here, I should have a way where I can determine how many vehicles are in the organization with a click of a what? A button. I should be able to determine that. That means in here, I'm going to create a new thing. I'm going to call it private total vehicle. And this is going to be an integer. And then
this vehicle constructor is what we use to make a particular vehicle. So when you make a particular vehicle, I want you to take the total vehicles and add 1 to it. That means that in here, we have to tell the computer that total vehicles is equal to what? 0. So that every time this constructor is called, 1 will be added here. Again, we would use the word super here to call the constructor here. And we are using the word super here and not the constructor name because this is extending from this, hence this is the parent. So if I want to refer to the constructor in the parent, I would use the word super. So anytime I call super here, the computer will come here, create this, and add 1 to this here. That means that I have to have a way in here that I will tell the computer what the person has what and how many vehicles are there at that current point in time. So in here again, I'll use alternate insert. I'll tell the computer I want a getter, not a setter, because the setter would be calculated the total vehicles will be counted 1 by 1 automatically. Hence, I would use a getter, and the getter is only for what? Total number of vehicles. So public int get total number of vehicles, returns the total number of vehicles that is found over here, and it will utilize that. That means that this side of the question here, over here, you need to track. I have done that. So the task, create all of this, I have done it. Add overloading and stuff, we'll do that in our next lesson, so I wouldn't worry you people with that today. Extend his base of class and claim we've done this, and explain how constructors are doing. I think during the entire lesson, I've explained what constructors are, I've explained why we use them, I've explained how to call a constructor in a child, how to create it in a parent. I think I have done that. So now, when I come to my main method, because everything has to pass through the main method, I've already created a constructor for a car. I've done that. So now I'll create one for all of these things here. So over here, I'll create one for a truck. So here will be new what? Truck. I'll create another one for a motorbike. So over here, it is also going to be a what? A motorbike. Then here, I'll just change the name to truck 1. And here, I'll change it to motorbike 1. Great. Now, of course, the truck, who can give me some name of a truck company? I think there's MAN. And then, let's see, Road Runner. And then it was done in 1990. And over here, a motorbike, let's see, Yamaha. And then over here, I'll have the model. I don't know any Yamaha model. Let's say XX1. And then the year 2001 is fine. That's fine. So in here, I've created 1, 2, 3 vehicles. Vehicles, right? This is the number of vehicles I've created in the organization. Now, I can tell the computer, go and take car 1. And when you take car 1, I want you to go and set the mileage to 15000. Go and take truck 1, and I want you to set the mileage to 30000. And go and take the motorbike, and I want you to set the motorbike dot. Oh, sorry. I need to use the object. So motorbike 1 dot set mileage to 5000. We can do that. I can say, okay, in the organization, car 1, what are the total number of vehicles that are in the organization? And I can do that. I can even do it with truck. I can do it with motorbike. And I expect that if I do it with any of them, I'll get the same answer. The same answer for all of them. Now, I can tell the computer that, okay, I want you to display to me one second. I want you to display to me the mileages of each car and then their engine capacities of the car. And the computer will do that for me. I also want you to display to me, so system.out.println these things here. So we are going to display these things here. So plus space, and here there will be none of this here. So that over here I had a plus here and I have a plus here. So I'm going to be showing the total number of vehicles for the car. I expect that this and this and this will have the same value. And here I'll display the mileages are entered here and the capacities of the car doors that I put over here. Here I said the capacity is 4, the engine capacity, the cargo capacity, let me make it 4,000. And here the engine capacity, let me make it 15000. I don't know if they are correct, it's just figures I'm entering. So if I run this, I can see that my car door is 4, my this is that, my this is that. Over here it's telling me that I have one bike, one that. But if I tell the computer that, okay, get me the vehicles, go to vehicles and get me the total number of trucks that are there. It will tell me that the number of trucks that are there from the vehicles is going to be what? 3. So today's class is us hammering down on the rules. In object-oriented programming, there are rules. There is a way we program when we are using object-oriented programming. First of all, you must know what a class is. You must know what an object is. An object and a class, they are connected together using a constructor. Once you know these things, you have to know the principle of encapsulation. That is, I want to hide or I want to keep all things about me private. I don't want another class to have access to my innermost data. And if you implement encapsulation, it means that you are going to be implementing setters and what? Getters. Once you do that, we can also reduce coding, reduce the number of codes and lines we write by implementing inheritance into our code. Inheritance will provide us to create child and parents, and the children will inherit properties from the parents. Hence, we do not have to code those properties twice. Are there any questions, please? Next week, when we come, we'll take the second question. The second question will allow us to treat the other properties of object-oriented programming, which are abstraction and polymorphism. We'll treat abstraction and polymorphism, and we'll add it to the encapsulation and the inheritance. Now, once we understand the principles of Java, which is classes, encapsulation, inheritance, polymorphism, and abstraction, then we can move into designing an interface using these properties. From there, we'll connect our system to a database and see how we can build a system that talks to a particular database and takes information from there and brings it to our system. From there, we will treat Android application development. How can we use Java to build an Android app that we can send to ourselves and share? Finally, is there any question anybody wants to ask? If there are no questions, then I'll bring the class to an end. Thank you all for coming this week. I'll see you all next week.